Hi, welcome to another video. So in this video today, I actually wanted to share with you guys a really cool and elegant geometry problem. And so the problem goes like this. And as I'm reading the problem, feel free to go along with the diagram that I drew to go along with it as an aid. And so in isosceles trapezoid ABCD, parallel bases AB and CD have lengths 500 and 650 respectively, and AD and BC have length 333. So the angle bisectors of angle A and D, and the angle bisectors of angle A and angle D meet at point P, and the angle bisectors of angle B and angle C meet at point Q. And the whole goal of this problem is to find the length of PQ. And so before you pause the video, I would just like to make one comment about the diagram. The reason why these four angles down here are equal is because because by the fact that it's an isosceles trapezoid, angle D will equal angle C, and so all these bisected, and so if we look at the angles formed by the angle bisectors to angles D and angles C, we'll get that all these four angles will be equal, and the same thing will follow because the trapezoid is isosceles. You'll also get that angle A is equal to angle B. And so the angles formed by the bisectors to angles A and B, all four of those angles all must be congruent to one another, which is why I denoted them in the diagram in this way. But anyways, with all that in mind, feel free to pause the video if you'd like to try the question. Yeah, so if you want to do that, and yeah, and so we'll keep going. After that, we'll keep going with the solution here. And so, yeah, and so in terms of solving this question, right, the first thing we can notice is that, right, so we were given that ABCD was a trapezoid. And so we know that AB and CD are parallel to one another, right, because those were the bases. And so what does that mean? Well, it means that angle D plus angle A has to be 180 degrees, right? By the fact these two bases are parallel to one another. And so, yeah, I'm going to refer to the angle with one tick to be, I'm just going to call it to be angle 1. And I'm just going to refer to the angles with two ticks to be like, I'm going to just call them angle 2. So we get that because angle A plus angle D is equal to 180 degrees, we get that 2 times angle 1 plus 2 times angle 2 is equal to 180 degrees. And so that basically implies that angle 1 plus angle 2 adds up to 90 degrees. And because angle 1 plus angle 2 adds up to 90 degrees, right, if we look at triangle APD, the sum of its angles must be 180 degrees, right? And so since these two angles of triangle APD add up to 90 degrees, the third one must cover the remaining 90 degrees. And so we basically get that angle APD, let's do this in blue, we basically get that angle APD is a right angle. And by similar means, we can say the same thing about angle BQC, right? And so this is what our larger diagram is. Sorry, I had to zoom in at times to be able to write on it. But with that in mind, the next thing we're going to do is we're going to introduce these midpoints, M of side AD and N of side BC. And so what can we, actually, let me just draw this M a little bit larger, sorry. Yeah. And so the thing that we're going to do is that, well, first, I'm actually going to refer to these, I'm actually going to, I'm going to denote some congruent segments in this diagram, and I'm going to, whenever I denote a segment with one tick, it basically means that that segment's going to be congruent to half of the length of segment AD. And so basically, yes, so I can now mark, I can now say that angle, that AM, MD, BM, and NC are all congruent to half of the length of segment AD, right? And so the next property that I'm going to use, now that I have that drawn and I've made that clear, the thing that we're going to actually do next in the problem is we're actually going to say that if you remember from geometry class in high school, if you take a right triangle it's the midpoint of its hypotenuse will be equidistant from will be its circumcenter, meaning that the midpoint of the hypotenuse of a right triangle will be equidistant from all of its vertices. And so if we do that, right, we get that AM is congruent to MD is congruent to MP. And now, since AMP is an isosceles triangle, we'll obtain that, right, so we'll obtain that angle MPA is congruent to angle MAP, which implies that angle MPA is congruent to angle 1. But now, we have these transversal angles in our diagram, right? We have MPA, and we also have PAB. And so, given these, we have those alternate interior angles. And so, given those alternate interior angles, it will actually now follow that MP and AB are in fact parallel. Okay, and so the next thing we can say too is we can do the same thing on the other side. We can connect QN, right, and because N is the midpoint of BC, right, so we'll get that N is the circumcenter, so BN is congruent to NQ, and so so then you basically get that angle BQN is congruent to angle 1 by the isosceles triangle. Sorry, this new iPad's absolutely killing me right now with the autocorrect. Okay. Sorry. And so you get that angle BQN is congruent to angle 1 as well. And so then by these alternate interior angles, it will follow that QN is parallel to AB as well. Okay, so I'm just going to erase this thing just to make the diagram clearer, but we get that QN is parallel to AB. And finally, since M and N are midpoints of, so I'm going to actually make one drawing down here, because M and N are midpoints of, because M and N are midpoints of sides AD and BC of the trapezoid ABCD with bases AB and CD, right? So MN will be the midline of this trapezoid, and so we know that MN will be parallel to AB and CD with line MN occurring halfway between AB and CD. This can actually be simply seen because if you drop a height from N to DC, it'll be half of the height from B to DC, and if you drop a height from M to AD, it'll be half of the M to DC. It'll be half the height from A to DC, right? And so you'll get that the heights from M and N to DC will be the same, which means the MN will be parallel to DC, and you'll also get the distances between MN and DC will be half of that from parallel lines AB and DC. So MN will be the midline of the trapezoid is a parallel line. This will be a parallel line that is equidistant from both sides of the bases of the trapezoid. And so now, I'm just going to write that MN is parallel to AB. And so now we have that MP, right, is parallel to AB, and MN is parallel to AB. And so what does that imply? That implies that MP and N are collinear, or in other words, that P lies on line MN. And so the other thing we can say too is we can say that because QN is parallel to AB and MN is parallel to AB, it follows that Q also lies on line MN. And so since P and Q both lie on line MN, it follows that PQ, M, and N are collinear, and so it actually follows that this line PQ turned out to be the midline of this trapezoid, which I find to be actually pretty incredible, to be a pretty incredible proof and a pretty incredible property. And so what can we do now that we know that PQ is in fact the midline of this trapezoid? Well, what we can say is we can actually say, right, so we know that MN, MP, Q, and N are actually collinear. what we can actually say is that, well, first, we know the length of MN will be the average of the bases of the size of the trapezoid, right? Because it's the midline. And so we basically get that MN is equal to 500 plus 650 over 2, which is equal to 575 is the length of MN. And we also obtain that if you sum up these lengths, MP and QN, MP and QN will be each congruent to half of the length of AD, so their sum will be equal to the, so the sum of MP and QN will be the same as the length of the entire segment AD, which is 33. And so we now basically get that segment, the length of MN will also just be the length of PQ plus 333 rather, right? So we basically get now that the length of MN will be basically the PQ plus 333. And so now we just obtained that PQ plus 333 is equal to 575, which implies that PQ has length 242. So there are actually other ways to do this problem as well, but to try to keep this video relatively short, I only decided to do one. Maybe I'll provide the other solution that I found to this question as well in the comments section below, because it actually is pretty insightful and it has some different things. Of course, if you find a solution to the problem as well, feel free to put it in the comments section below. And actually, I'd just like to talk a minute about where this problem actually came from. So this problem actually came from an exam called the American International Mathematics Exam, or shorthand it's called the AIME. The AIME is the second round of examinations in the U.S. process in determining which six people will be the people to represent the U.S. on the International Math Olympiad. And yeah, it's a process that occurs for high school students and below. But yeah, so each country, their International Math Olympiad is an Olympiad where all different countries compete against one another. It's called it's abbreviated the IMO. And yet each country sends 6 teams to the International Math. Each country sends a team of 6 people to the International Math Olympiad. And yeah, and so the U.S., each country has its own process. So in the U.S.'s process, the first round of contests is the American mathematics competitions, the AMC 10 and 12. And then the second round is the AIME, or the American Invitational Mathematics Exam. And so, yes, and so this problem actually particularly came from the 2022 AIME 1 problem 3. And so the AIME is actually a contest where you have 15 problems and you have 3 hours to solve them. Yeah, and it actually is quite a hard exam. As you can see by this problem, this problem was actually only a problem 3 from the exam from one of the recent exams. But yeah, I just wanted to say that the contest that it came from, but yeah, it came from the American Invitational Mathematics Exam. But anyways, I hope you enjoyed the problem and the solution I presented to it. I thought it was actually a really cool problem overall. There's just something about this problem that just seemed really aesthetic to me, which is why I decided to make a video on it. But anyways, I hope you enjoyed the video, and I will see you guys next time.